In this video, we'll take a look at section 7.1, which is the basics of solving quadratic equations. Now, our first objective is the principle of square roots. Now, when we have an equation of the form ax squared plus bx plus c equal to 0, this is called standard form for a quadratic equation. Now, our first example, we're going to use the method that we've seen previously in section, I believe it was 4.8, when we were solving quadratic equations. Now, what we did to solve quadratic equations is we factored, and then we set each factor equal to 0, and then we solved each equation. So for our first example, we have 4x squared plus 14x equal to 0. So to begin to factor this out, first thing that I notice is there is a GCF of 2x. So I can factor out a 2x, and now I'm left with 2x plus 7. And I have equal to 0. Well, now I go ahead and set each factor equal to 0. So I have 2x is equal to 0, and then 2x plus 7 is equal to 0. Now we solve for x in each equation. So first one, divide by 2. Second equation, I'm going to subtract 7 from both sides. Now going back to the first equation, I get x is equal to 0. In my second equation, I get 2x is equal to negative 7. So I still have to go ahead and divide both sides by 2. I get x is equal to negative 7 over 2. Now our next example, solve, we have x squared is equal to 16. So first I would have to go ahead and get one side equal to 0, so subtract 16 from both sides. So I get x squared is equal to, I get x squared minus 16 is equal to 0. And now I could factor, well, this is a difference of two squares, so this factors into x minus 4 times x plus 4. Now go ahead and set each factor equal to 0. So I have x minus 4 is equal to 0, x plus 4 is equal to 0, and then solve each equation. So first one, add 4 to both sides. Second one, subtract 4 from both sides. I get x is equal to positive 4 and x is equal to negative 4. Okay. Now this leads us to our square root principle. So those previous two examples, we used the same methods that we saw in section 4.8. We factored and we set each factor equal to 0. Now with the square root principle, what this states is if x squared is equal to a, then x is equal to the square root of a, and x is equal to negative the square root of a. So the steps for using this square root principle, first you're going to isolate the expression that is squared, and then you're going to use the square root property. Another way that you could rewrite this square root principle is x is equal to plus or minus the square root of a. So when you take the square root of both sides, you have a plus or minus on the right hand side. So let's take a look at this next example. So we have x squared is equal to 36. So my expression that's being raised to the second power is already isolated. So what I'm going to do now is go ahead and take the square root of both sides. And now on the right hand side, just remember that plus or minus. So square root and second power, these cancel out with each other. So I have x is equal to plus or minus the square root of 36. But now square root of 36, we could simplify that. We get x is equal to plus or minus 6. But just be careful here. This gives us two solutions. We get x is equal to negative 6 and x is equal to positive 6. So for this particular problem, we didn't have to get one side equal to 0. We didn't have to get it to standard form. If we did, we'd have x squared minus 36 is equal to 0, which factors into x minus 6 times x plus 6. And you set each factor equal to 0, and you still get the same solution. You still get x equals negative 6 and x equals positive 6. Let's take a look at another problem. This time we have 5 squared is equal to 15. Sorry, 5x squared is equal to 15. Now in this particular problem, our expression that's squared is not completely by itself. We have that 5 in front of the x squared. So let's go ahead and divide both sides by 5. And now this gives us x squared is equal to 3. Well, now I go ahead and use my square root principle. So take the square root of both sides. Just remember your plus or minus. So square root second power, cancel out. I get x is equal to, I have plus or minus the square root of 3. Remember that gives us two solutions. We have x is equal to negative square root of 3 and x is equal to positive square root of 3. Let's take a look at another one, a little bit more challenging. We have negative 25x squared minus 36 is equal to 0. Okay. Well, first, we have to isolate the expression that's being squared, so let's add 36 to both sides. We get negative 25x squared is equal to positive 36. And now we go ahead and divide both sides by negative 25. So this leaves us with x squared is equal to negative 36 over 25. We have the expression that's being squared isolated. Let's go ahead and take the square root now. Just remember we have a plus or minus. So now we have x is equal to plus or minus the square root of negative 36 over 25. But we could simplify that. First, since we have a negative inside our square root, we could pull out an I. We have times the square root of 36 over 25, which could be simplified even further. We get x is equal to plus or minus, so square root of 36 over 25. Remember, take the square root of the numerator, take the square root of the denominator. We get 6 over 5. We have our I on the outside. So yeah, x is equal to negative 6 over 5i. And x is equal to positive 6 over 5i. Next problem, we have x minus 1 squared. 1 second. Okay, so we have x minus 1 squared equal to 5. Now for this particular equation, our expression that's being raised to the second power is isolated. So what I want to do now is I want to get rid of that second power. So I have to take the square root of both sides. Put my plus or minus. So now square root, second power, cancel out. So I have x minus 1 is equal to plus or minus the square root of 5. It wasn't letting me write at first. So I have x minus 1 is equal to plus or minus the square root of 5. Now if I want to solve for x, let's go ahead and add 1 to both sides. I get x is equal to 1 plus or minus the square root of 5. Just remember this gives us two answers though. We have x is equal to 1 plus the square root of 5, and x is equal to 1 minus the square root of 5. Now 1 plus the square root of 5, I can't actually add these together. So I have to leave it the way it is. And the same thing with 1 minus the square root of 5. Next problem. So we have 3 times x plus 2 squared plus 27 is equal to 0. So let's begin by isolating the expression as being squared. So let's subtract 27 from both sides. So now I have 3 times x plus 2 squared is equal to negative 27. Now divide both sides by 3. I get x plus 2 squared is equal to negative. Now 27 divided by 3 gives me 9. Well, now let's get rid of that second power. So go ahead and take the square root of both sides. Square root, second power, cancel out. I get x plus 2 is equal to, now square root of negative 9, I have plus or minus, this gives me 3i. Now next step to solve for x, go ahead and subtract 2 from both sides. We get x is equal to negative 2 plus or minus 3i. So we get x is equal to negative 2 plus 3i, and x is equal to negative 2 minus 3i. So we were solving these equations using the square root principle. Now this leads us to our next objective, which is completing the square. Completing the square allows us to rewrite our equation into that form where we have an expression squared and then equal to some number, and then we could use the square root principle. So now steps when we're completing the square. So we have a generic quadratic equation here, ax squared plus bx plus c equals 0, so it's in standard form. Now our first step is to divide by a if a is not equal to 1. So if your coefficient of x squared is not 1, you're going to divide each term by that number. Step 2 is to isolate the variable terms, meaning get your x's on one side and get the constant on the other side. And now step 3, this is the completing the square step. You're going to take half of the coefficient of x and square it. Add the result to both sides of the equation. Now the reason for step 3 is because now in step 4, you could factor it into a perfect square binomial. And then step 5, use the square root principle. Let's take a look at this example. So solve by completing the square. Okay, so first we have to take a look at the coefficient for x squared. So since the coefficient of x squared is 1, we don't have to divide by anything. Just leave it the way it is. Next, it says to isolate the variable terms. So let's move our constant to the other side. So let's add 16 to both sides. So I have x squared plus 6x is equal to 16. And now is the completing the square part. So we're going to take half of the coefficient of x, so we're going to take half of 6, and then square it. So essentially what we're doing is we're taking 6, dividing it by 2, and then raising it to the second power. So 6 divided by 2 gives me 3. So I have 3 raised to the second, which gives me 9. So I'm going to add 9 to both sides of the equation. So I have x squared plus 6x plus 9 is equal to 16 plus 9. Now, since I added 9 to both sides, my equation is still balanced. Now, on the left-hand side, x squared plus 6x plus 9, this factors into x plus 3 times x plus 3. But instead of writing it out twice, I can rewrite it a different way as x plus 3 raised to the second power. So I have x plus 3 raised to the second power is equal to, now 16 plus 9, I get 25. Now I have it in the same form as those previous examples that we saw. So in order to continue to solve it, now I can go ahead and use the square root principle. So take the square root of both sides, over your plus or minus. So square root second power cancel out. I get x plus 3 is equal to plus or minus. Now the square root of 25 gives me 5. Okay. Now one last thing to solve for x. Subtract 3 from both sides. We get x is equal to negative 3 plus or minus 5. Okay. But now let's split up our answers. Let's write out our two solutions. So I have x is equal to, I have negative 3 plus 5. And I have x is equal to negative 3 minus 5. So now I could actually add those together. Negative 3 plus 5, I get x is equal to 2. And x is equal to negative 3 minus 5, that gives me x is equal to negative 8. So my two solutions here is x equals 2 and x equals negative 8. Let's take a look at another example. So we have x squared minus 18x equal to 10. So working this out, first, the coefficient of x squared is 1, so I don't have to divide by anything. My variable terms are already isolated. They're on one side of the equation. So now completing the square, I take half of 18. So I take 18 divided by 2. And I'm going to raise that to the second power. So I get 9 raised to the second, which gives me 81. So now 81 I'm going to add this to both sides of the equation. So I have x squared minus 18x plus 81 is equal to 10 plus 81. So now when we factor the left-hand side out, I have x minus 9 raised to the second power. So it would be x minus 9 times x minus 9. But I could rewrite that out as x minus 9 to the second. Then I have equal to, so 10 plus 81 gives me 91. So now I have in the form that I want, so I could go ahead and take the square root of both sides. Square root, second power, cancel out. I have x minus 9 is equal to plus or minus the square root of 91. Next step, get x by itself, add 9 to both sides. I get x is equal to 9 plus or minus the square root of 91. Okay, writing out our two solutions, we have x is equal to 9 plus the square root of 91, and x is equal to 9 minus the square root of 91. Square root of 91, we cannot simplify it, and we cannot add it or subtract it from 9. So these are our two final answers. Another example, so we have x squared minus 8x plus 15 is equal to 0. So first, our coefficient of x squared is 1, so we don't have to divide by anything. But now we want to isolate the variable terms, so let's go ahead and subtract 15 from both sides. We have x squared minus 8x is equal to negative 15. Now we take half of our coefficient of x, so we're going to take 8 divided by 2, and then we raise that to the second power. So we get 4 raised to the second power, which gives us 16. So 16, I have to add that to each side of the equation. So I have x squared minus 8x, x squared minus 8x, plus 16 is equal to negative 15 plus 16. So now the left-hand side factors into x minus 4 times x minus 4, or if I rewrite it, it's x minus 4 to the second power, which is equal to negative 15 plus 16, which is 1. Now let's go ahead and take the square root of both sides. Square root, second power, cancel out. I get x minus 4 is equal to plus or minus, now square root of 1 gives me 1. Continue, let's go ahead and add 4 to both sides. This gives me x is equal to, I get 4 plus or minus 1. Now, if we separate our answers, we get x is equal to 4 plus 1, and x is equal to 4 minus 1. So from our first equation, this tells us that x is equal to 5, and x is equal to 3 from our second equation. Let's take a look at another one. This one a little bit more difficult. Okay, we have 2x squared plus 6x is equal to 5. Now we do have a coefficient for x squared. So there is a number in front of our x squared that isn't 1. So we're going to divide each one of these terms by that coefficient. So we're dividing everything here by 2. So I have x squared plus 3x is equal to 5 over 2. Next step was to isolate the variable terms, which in this case they are already isolated. So now I have to take half of the coefficient of x. So my coefficient of x is 3. So I'm going to take half of 3. So I get 3 over 2. And now I'm going to raise that to the second power. So 3 over 2 raised to the second power gives me 9 over 4. So I have to add 9 over 4 to both sides of the equation. I have x squared plus 3x plus 9 over 4 is equal to 5 over 2 plus 9 over 4. Now on the left-hand side, this is going to factor into x, and it's always whatever this sign is, so x plus, and then whatever half of 3 was. So half of 3 was just 3 halves. And I've raised to the second power. So that trinomial factors into x plus 3/2 times x plus 3/2, which we could rewrite as x plus 3/2 raised to the second. Now I have equal to. Now on the right hand side I have to add these two fractions with each other. But in order to add the fractions with each other, I need the same denominator. So the 5/2 changes into 10/4, and I have plus 9/4, which gives me 19/4. Now let's continue. Go ahead, take the square root of both sides. Square root second power cancel out. So I have x plus 3/2 is equal to plus or minus. Now remember, with square roots of fractions, take the square root of the numerator and take the square root of the denominator. So I have square root of 19 over, now the square root of 4 gives me 2. Next step to solve for x, go ahead, subtract 3/2 from both sides. I get x is equal to negative 3/2 plus or minus the square root of 19/2. So this gives me two solutions. I get x is equal to negative 3/2 plus the square root of 19/2, and x is equal to negative 3/2 minus the square root of 19/2. And these are my final answers. Let's go ahead, let's take a look at one more problem. So I have 3x squared minus 2x is equal to 7. So my coefficient of x squared is 3, so let's go ahead and divide everything by 3. So I get x squared minus 2/3 x equal to 7/3. And now in this particular problem, it's a little bit trickier because now I have to take half of this fraction and then square it. So what we've seen before is to take half of a number, you could just divide it by 2. Another way that you could take half of a number is to multiply it by 1/2. So when I'm dealing with fractions, it's a little bit easier just to multiply the 2/3 by 1/2 to figure out what half of 2/3 is. Let me just write this in red. Okay, so I'm going to take half of 2/3. So I'm going to multiply 2/3 by 1/2, and I'm going to raise that to the second power. Well, if I'm multiplying fractions, I could cross cancel. So I really have 1/3 raised to the second power, which gives me 1/9. So I have to add 1/9 to both sides of my equation. So I have x squared minus 2/3 x plus 1/9 is equal to 7/3 plus 1/9. Now the left-hand side, it's always going to factor into x, whatever the sign is. So I have x minus, and then whatever half of 2/3 was. So half of 2/3 was 1/3. So I have x minus 1/3 raised to the second power equal to. Now I have to go ahead and add these fractions with each other. So 7/3 plus 1/9. I have to have the same denominator. So that 7/3 is going to change into 21/9. So multiply top and bottom by 3. I have plus 1/9, which gives me 22/9. Almost finished. Go ahead, take the square root of both sides. Don't forget your plus or minus because we're getting two solutions here. So I have x minus 1/3 is equal to plus or minus square root of 22 over 3. So take the square root of the top number, take the square root of the bottom number. And now let's go ahead and add 1/3 to both sides of the equation to get x by itself. So you have x is equal to 1/3 plus or minus the square root of 22 over 3. And now if I rewrite it to two separate answers, I get 1/3 plus square root of 22 over 3, and x is equal to 1/3 minus the square root of 22 over 3. And now I have my two solutions. So now the reason why we have this method for solving quadratic equations is because we won't be able to factor out every problem that's given to us. However, that doesn't mean that there isn't a solution to that equation. So we have this other method that we can use to solve that equation. Okay. So for example, if we go back up, for this example, we couldn't factor it out. You wouldn't have been able to factor it out. Same thing with this example. You wouldn't have been able to factor it out. For this specific example, we were actually able to factor this out, which we could have used that factoring method to solve. For this problem, let's try to take a look at how if we could factor it. So I can tell just by my solutions, I wouldn't have been able to factor this out. I would have x squared minus 18x minus 10 is equal to 0. So I have to get into standard form, meaning get one side equal to 0 first. And now I would need two numbers that multiply to give me negative 10 that add up to negative 18, which is impossible. So this would not be able to factor, you wouldn't be able to factor this out. However, there is still solutions to this equation. So we have to use this other method called completing the square to solve it. And that's how we got 9 plus square root of 91 and 9 minus the square root of 91. Okay. So that was it for section 7.1. As always, if you have any questions, just email me and I'll help you out.